Hello and welcome to the first of our series of demonstration videos for the VPAT tool. VPAT is a proprietary tool that was developed by Vicom Infinity to help assist with mainframe performance analysis and capacity planning. It is a very lightweight tool that resides in your PC, and you would literally download data to it, and then you perform your analysis. So the work is performed off of the mainframe. VPAT gives us access to RMF CPU and delay data, and it allows us to look at it visually. The tool includes drill-down features to help us navigate through the performance data and better understand usage and delay metrics. The tool also greatly enhances capacity planning through various processes that allow you to specify growth at different levels, from the entire KEK down to individual LPARs, down to even different workloads within LPARs. The tool allows you to combine multiple LPARs or multiple KEKs from dissimilar systems and plot their anticipated requirements together against available CPU system configurations. And you're using either LSPR or ZPCR generated CPU capacities, so the accuracy is very high. And this adheres to IBM's desired practices. One of the biggest challenges of mainframe data is the volume of data that's written. Many tools and products write extensive amounts of data SMF. So instead, VPAT leverages RMF data, which is typically written in 15-minute intervals, and that results in sets of 96 observations for the entire day, which is vastly smaller, and it still allows us to give us very good information regarding system performance and delays in the system. So the tool accepts data in either the format from a normal RMF report, CPU report, and that would be brought to the PC in text format, or it can be packaged in a compressed format, which would use the IBM ZPCR CP3000 toolset. And that would produce an EDF file, and that's the same EDF file that you would use as input to ZPCR. And that file would be brought to the PC in binary format. Now, VPAT can be used in two different modes. It can be used as part of a regular, ongoing, continuous process where you collect data regularly, perhaps daily, and you feed it to the product. The product has the ability to run in batch, so it can collect and absorb your new data as it's imported into it. Or you can use it as an ad hoc, on-demand type of tool where you would import data and analyze on demand and produce your results. Now, the subsequent videos in this series are going to take a look at the most common functions in the product and demonstrate how to use them in a basic mode. We're going to, so the basic features in the product are the extract process. Now, extract is how we described earlier. This is how we take data in either RMF or EDF format, and we produce output files that are in VPAT compatible format. The next one up that we're going to look at is analyze. And when we look at analyze, this is where we're taking all of our VPAT provided formatted files here, and we have a number of different graphing options against them and analysis options that we can use. Capacity planning is a major function in VPAT. This allows us to take a series of files from either individual LPARs, KEKs, etc., and combine them together as desired, and plot them against anticipated capacities that we're going to select from here, in which case we can even select these straight from the LSPR table. We can specify growth here compounded annually, or we can actually go in and modify workloads at the LPAR or individual service class level within LPAR. Another function here is YTD. YTD allows us to combine multiple daily or weekly files and produce longer-term tracking files that allow us to look at behavior over longer terms of period of time without having to maintain excessive amounts of data. We can store the data in either average or percentile format, which allows us to look at the granularity of the data and just how performance varies at the high end if we want to. Projection is another function within VPAT, and this allows us to take one of our YTD files and essentially look at the least sum squares trend line against the historic data and plot it against a series of anticipated capacities to know when we may need to upgrade or we may need to expand our system capacity. We can also look at LPAR defs, which are over here. And LPAR defs basically allow us to look at the actual configuration of our system at any interval while it's running, while it's up. And this can help us look at configuration issues or understand how our system's configured. The last functions that we will demonstrate in the series of videos will be an introduction to the simulator function. And the simulator function is essentially the creation of a model workload, and then allows the simulation of this workload to be run on different target configurations and different target capacities to anticipate performance on the system, not just total usage. And this brings us to the end of our first video. Please stay tuned to the next video where we're going to demonstrate how the extract process works. Thank you very much.